Hey guys, today we're going to be doing a 92 to 94 LS400. This one's going to be using the automatic gearbox, but we've got some tasty treats for this one for you guys, so let's get into it. Right, so as I said, this is going to be a 92 to 94 LS400. This one in particular is going to be an automatic, so it's going to be using the auto gearbox. But we do have a little new addition to our harnesses that we're going to show you regarding the auto gearboxes and manual gearboxes. But first thing we're going to do is, as I say, brand new harness. We're going to take you through the build process, show you all the sub harnesses that are part of this harness, and then we'll come back. So see you in a second. Right, so now you can see exactly what goes into making one of these harnesses, what it looks like underneath all of that heat shrink there. So what we're going to do today is our usual stuff. We're going to be doing the layout of the harness, so we're going to go through all of that. We're going to go through some nice new additions to this particular harness the customer required. And obviously then we'll jump into the testing, which is going to be made up of two sections, one with just the ignition on and one with the engine actually running. So let's start with the layout, and let's start right here at the ECU, because that's the simplest part. So on the ECU, we've got 4 plugs, 1, 2, 3, 4. They are all unique, so you can't put the wrong one into the wrong place, so don't worry about that at all. Coming out of the harness over here, we then have a plug that goes into the fuse box, and that's all the controls from the ECU going to the fuse box, controlling relays, etc. Then coming out of there, we have all the powers that are going actually into the harness itself, and again, they are all coming from the fuse box, so things like injector coil, power starter, solenoid, etc. Right, once we move along from there, we're then going to end up at our grommet, again, which is heat shrunk down, and popping right out over there is going to be our igniters. So you can see our igniters over there. You can see that they are clearly labeled igniter left and igniter right, okay? These are obviously designed, they have to be earthed, so we've brought them out here by the grommet so you guys can fit them on your firewall, etc., out of the way, instead of having them right in the front of the engine where they used to be. No need to have them all the way over there. Once we move along from there, we're going to come up to here and we end up at our usual molded T-piece boot over there. So the harness is going to go that way and it's going to go that way. So first thing we're going to do, let's go this way, and then we'll come back and see what pops out over there. So again, nice and simple, just runs along there like that, underneath there, underneath the cover over there, and it splits out at the front over here. What it's splitting out to is the cam for the left banks. Remember, this is the left bank, that's the right bank. Cylinder 1, 3, 5, and 7. Cylinder 2, 4, 6, and 8 on the other side there, okay? And you do have 2 cam sensors. One is underneath there. We'll get there in a minute when we go around the other side. But moving along, you then have a little mounting point over here, so you can then clip the harness there to keep it out of the way of everything. Pops along down here behind this coil over here, and it's going to split out into a few sections. As you can see, the first section is the coil itself, so really self-explanatory there. And then down here, you're going to have a split that's going to go through that hole over there, down through over there, so you can see where my finger is over there, pops out down here, and it goes to your crank sensor. And again, everything is labeled for you guys, so you can see all the labels there so you can't get them all wrong. Also popping out here is going to be, and going through that little hole over there, is going to be your oil pressure switch. So that is down there. Again, everything nicely labeled for you. The last section that pops out through here is going to be your Lambda sensor. Obviously O2 sensor is what they commonly refer to, so again, you see nicely labeled. Now, What some of you may notice, obviously, originally the harnesses used to bring the O2 sensor down there. We want to keep it away from the heat, so obviously we bring it down through here so it can run alongside there, not get anywhere near the exhaust and not get hot. That'll help save your connectors and obviously not risk your wires ever touching on the exhaust and melting. Right, so that is that section over there, nice and simple and straightforward. What we'll do now is we'll move over to the back here. Now, we do have quite a bit going on here, so I'm going to be here for a while when we go through it all. But I'm going to start with the easy stuff. So again, popping down there, we have our ground strap. So that is going to bolt over there. Just to be aware, there's a bolt down here, but it has a rather large hole at the back. Our ring terminals are not designed for that section over there. They must go into this section over here. It's a smaller hole with a flat surface, and that will bolt down there nicely. Again, you can actually see there's a hole there as well and there, but the top one that you're using for this harness. Okay. Moving along here now, I'm just going to show you here, we have the sub harness and that goes underneath. So what I'm going to do is I'm going to cut to a picture now. You'll see that it runs along, branches off and goes to the starter solenoid, runs along, branches off again, and it goes to knock sensor 1 and knock sensor 2. Right, so just remember guys, knock 1 refers to bank 1, which is this side, the left bank, and knock 2 refers to bank 2, which is the right bank over there. So just when you are putting that in, just make sure you're aware of that. Right, so moving along then, we're going to have our usual, which is our idle speed control and our injector. So that's your 12-pin DTM and your 6-pin DTM over there. Now, joining it in this particular case is going to be our TPS/MAF sub harness. Now, in this particular case, the customer has expressed an interest in wanting to supercharge the vehicle later on. So what we have done in the event that you do supercharge, obviously your throttle body and your mass airflow sensor are going to move. So what we've done is we've sub-harnessed that off for him so that basically when it comes time, he can send us the measurements of where his TPS and his MAF sensor will be. And obviously then we can then make him a new harness and send it to him in the post, and it can plug straight in, plug the old one out, plug the new one in. No need for any alterations there. Now, obviously, that's something we've done specifically for this customer, but I am open to suggestions. If you guys think that it is a good idea that we do this moving forward, then obviously it's something we can definitely look into as well. Okay, so now you have the injector, the ISC, and the TPS MAF. So how do they go? So what we're going to do now is we're going to cut to a photo. So you'll see they go in the middle of the intake, and your injector ISC harness will then branch off and go to the left injectors, and then to the right injectors, again, all nicely labeled. The harness will go along the front there and then pop out to go to the ISC, or idle speed control valve. And at the same time, you'll see the TPS MAF harness basically runs along with that, branches out to go right to go to the TPS, and it carries on straight to come out of the front and then go over to the MAF sensor, which we'll take a look at in a minute. Okay, so those are those 3 little sections over there. So again, the intake comes off in 2 sections. So you're going to take the whole intake off to do the sub harness, and then the middle section off to do the TPS MAF, injector, and ISC. Now, obviously, that means that you no longer have to disconnect every single injector and so on to remove the intake. You can actually do it by just removing these plugs. Just be aware of the MAF plug, which you'll have to remove as well. But that'll all come off with the entire intake, so you don't have to unplug everything apart from the MAF and these plugs over here. Right, now this is a new addition that we actually are going to start implementing on all our non-VVT-i harnesses. And you'll see here we have gearbox 1 and gearbox 2. So that means in this case, we are running down to the gearbox harness. So I'll run along through there, just plugs into those 2 plugs over there, runs along, branches out there, and it goes to our NCO speed sensor. So that is on the left bank of the gearbox. So again, left bank, right bank. Left side of the gearbox, you have your NCO speed sensor. Then it branches out and goes to the selector at the same time. Now the selector is on the other side of the engine. So that's on the right-hand side of the engine. Also coming out there is going to be your solenoid plug, so your 8-pin solenoid plug, your SP2, which is the output speed sensor for the ECU. And in the case of these 92 to 94s, they actually have a 3-wire Hall effect speed sensor, so we do include that. This particular customer, he actually wants to go to cable, so he's not going to be using that. He's going to actually be using a cable sensor on the back of the auto box in place of the electronic one. All right. But what this means for you guys now is that basically all of our base harnesses are going to work whether it's auto or manual. And we are also going to put the provision in when you go for a manual setup that you can add a reverse switch and a speed sensor if you so desire. And You will also be coming up soon a 3UZ with the exact same system. So again, it's really nice. It makes the harnesses much more sellable for you guys when you do want to sell them on. If you change your project or don't want to have the car anymore, when you sell these harnesses on now, they will work both for an auto and a manual. You're not restricted in terms of who you can sell to. So this could be sold to a guy with a manual. Phone us up, we'll get the manual adapted plugs to go on there. If a guy wants to stay auto, he can just keep that harness over there. Okay. Right, so that is that section over there. Like I said, quite a lot going on in the back here, and obviously the new addition there and this one, which we may consider doing. Depends on how you guys feel about it and if it's something that you guys would be interested in. Right, so what I'm going to do now is I'm going to move over to the other side so we can carry on going around here. So again, harness will carry on over there. You can see you've got some bolts over there to clamp it down with some P-clamps if you want. And again, over here under the TPS. As you can see, the TPS is obviously coming out from under the inlet over there. So that's where that plugs in over there. Now that harness that runs along there runs all the way to the front, and then it breaks out here at the front. Now what we've got is we've got our temp wire. Now in this case, what we've done is we've left it loose so the customer can put whatever temperature sensor he's requiring for his dash. And we have our coolant temp sensor over here. So I'm going to try and see if I can get it. There you go. You see the gray plug over there. Fantastic. Also coming out there is the coil plug. So exactly the same like the other side there. It just plugs in directly over there. And then lastly, coming underneath here, you can see your cam for the right bank over there. So there's your cam sensor there. And that all pops out over here. Now running along here, you can actually see we've got two separate wires. And what I'm going to do is I'm going to show you that this is the mass airflow sensor. So we've got plenty of length there. So wherever your MAF ends up, you've got loads of room to go there. But coming out this little section over here is going to be that. So if you guys want, you can cable tie these together just to keep it nice and neat. But that comes down along here, and then it goes to our alternator sub harness. So again, like with everything else, it's all labeled up for you guys there, alternator. And in this case, on the 92 to 94s, you have the oval plug, not the round one. That's for the 89 to 91. So again, this can be interchanged. So if you ever needed to put a higher RAM alternator or whatever on, this sub harness can be changed for whatever alternator you require. At this breakout point over here, obviously the other section pops down there, goes along there, and it ends up at our Lambda sensor over there. So again, as per usual, we're only using the two Lambdas that are in the exhaust manifolds, not the ones that are after the catalytic converters. Okay, so nice and simple and straightforward. Right, so hopefully that helps in terms of the installation, especially the pictures of the underneath the inlet manifold there, so you can actually see what should be going on there. All right. So now that we've done that, let's move over to the fuse box plugs. So we have our usual 9-pin plug over here that I'm going to go through, and then we have our automatic gearbox plug over there as well. So let's start with the 9-pin plug. And again, if you've watched any of our other videos, this is going to be a mega repeat for you guys. But for our customer, we're going to go through everything in detail now. So starting at pin number 1, which you can see here is a red wire, which is this one over here, because obviously I'm supplying the power over there. That is a permanent 12-volt supply. Now, it does need to be a permanent 12-volt supply, and the reason being is for diagnostic purposes. The ECU stores codes, and so what happens is one of the feeds coming out to the ECU is a permanent 12-volt supply to make sure that those codes are stored and that you can get them again after you switch the ignition off, okay? Now, if you had to connect that red wire to an ignition source, what effectively it would mean is that every time you turn the key off in the car, you would reset the ECU, you would clear all the codes, and it would make diagnosing any issues incredibly difficult because you could only check the codes with the engine running, because the second you turn the key off, boom, codes are gone. So please, I do stipulate in the instructions, but it must be a permanent 12-volt supply. If it's in a vehicle with a cutoff switch, that's absolutely fine, as long as you're aware of what it is. But you can still do diagnosis because you can turn the ignition on and off and on and off, as long as you don't kill the kill switch. Right. Then number 2 is going to be black with a yellow, and that is your start signal. So that is a really nice and simple one. It's just a 12-volt feed in. So again, it can be got from the back of your key barrel. If you're going to install a switch, you can just put ignition 12 volts to one side, our black with a yellow wire to the other side, no problem. Next up is number 3, and that's yellow with a green, and that's that gauge temp. It's that temp wire we were talking about earlier. This one over here. So what we've done is we've brought it inside the vehicle so you guys can remove this sensor over here, replace it with whatever you need is going to work for your dash, and then obviously you can just put whatever terminal or connector is required for that particular sensor. And that'll obviously come in there, and you can run that to your gauge, to your aftermarket gauge you bought, etc. Right. Then number 4 is gray, and that is your fuel pump. So at the moment it's over here because, again, I've got the fuel pump hooked up to my thing to start the engine. Now, this is capable of running straight to a fuel pump and providing 12 volts. If for whatever reason you have a very big pump or pump that draws a lot of current, then obviously you can use that as a 12 volt trigger for a relay in the boot where the fuel pump is, and you can run a thicker battery cable to that relay for that particular purpose. All right. Now, in this case, I do have links in the description on a whole bunch of useful videos. One of them is how the fuel systems work. Now, in this case, in 92 to 94, they actually used a fuel pump ECU. So what we have done is we've actually utilized a system where we use the oil pressure light to keep the fuel pump alive, or vice versa, turn it off. So in that case, if you had to lose oil pressure, the fuel pump would actually shut down. And I'll show you another little thing that it does if you don't connect the oil pressure switch, because if you don't connect that, then the fuel pump will run constantly. So please always make sure the oil pressure switch is connected before you turn on the ignition. Otherwise, you're going to have the pump running all the time. Okay, so that's great. Let's move over to number 5, which is yellow with a red, and that is your check engine light. So in each fuse box, we do put a check engine light for you, the little LED over there. So again, before you even connect everything up, you can just make sure that you have a check engine light. It tells you that the ECU is turned on. But we also give you the yellow with the red, and in this case, it's connected to our cluster. So we're going to use that to test and make sure that that yellow with the red is working exactly as we expect it to. Next up is number 6, that's yellow, and that's going to be our tacho signal, or rev counter signal. That is coming from the igniters. Now, what you'll notice is we've got 2 igniters, we've got 2 distributors, we've got 2 coils. Basically, it's 2 4-cylinders together. So because the signal, the tacho or rev counter signal is only coming from one of the igniters, you are going to end up with a 4-cylinder signal, not an 8-cylinder signal. So if you are using aftermarket gauges, make sure that you have the ability to select 4, 6, and 8-cylinder. So you can put it on 4-cylinder and you'll get a correct reading. All right. Next up is number 7, and that's black with a red, and that's going to be your ignition feed. So that's the one that's actually going to turn the system on, and that you're going to either get from the back of your key barrel, or if you're fitting a separate switch for the ignition, no problem at all. Permanent 12 volts to one side of the switch, other side of the switch to our black with a red tracer, and that becomes your ignition switch. Now, little tip for you guys, if you are using a key barrel, please bear in mind that there are 2 12 volt feeds at the back of a key barrel. Usually one is accessory and one is ignition. The only reason I mention this is because accessory loses its power when you turn the key to the start position. Okay, now what that means is if you use that to connect to our black with a red wire, every time you turn the key to the start position, you'd effectively shut the whole system down. You'd be turning the ignition off. All right, and it'll be frustrating because you'll go to crank it, it won't start. And then as soon as you let go of the key, obviously everything comes alive again and you think, what is going on? And it's going to drive you insane. So please make sure that that red with the black wire gets an ignition 12 volts and it remains to have ignition 12 volts when the key is moved to the start position for the starter motor. Okay, and just a note as well, all these wires here are incredibly thin. That's because they're not actually powering anything. They're just activating relays in that harness there for you guys. Next up is going to be number 8, that's pink with the blue, and that is going to be your charge light. So that is from your alternator, charge light, alternator light, battery light, whatever you want to call it. Basically, that is going to come from there. It is a ground, so if you are going to fit your own LEDs in your dash, if your dash didn't come with an alternator light, then again, 12 volts ignition to one side of the LED and the ground side to our pink with the blue wire. You'll see at the moment it is connected in there because I'm going to translate the MPX data on the IS200 cluster there, so we can have the alternator light which will appear there and the oil light which will appear there. Okay. And then last on the 9-pin plug is going to be yellow with a black, and that is going to be oil pressure. So again, that is from your oil pressure switch, which is down there. That is again a ground. Now that literally comes straight from the switch, straight into the fuse box, straight out that black with a yellow wire. So there's nothing involved with that one, so nothing super complicated there. And you can see it's in there. And oh, I nearly forgot, with the alternator light, you guys need to be aware that on some older clusters, we have experience where the cluster is back feeding into the alternator light, which is feeding back into the alternator, which is feeding back out because there are ignition and permanent 12 volt supplies in the alternator connector. And I've had instances in the past where the ECU, the fuse box and everything has been kept alive, where it's been back feeding through the alternator. So If you have an old dashboard, two things you can try and do. One, if you're lucky enough and you can get LED bulbs instead of the normal incandescent bulbs, that's fantastic because an LED is a diode and therefore it'll stop the backfeed. If that's not the case, then the easiest thing to do is just fit a diode in that pink with the blue wire, just to make sure that you can't backfeed into the alternator from the cluster and therefore keeping the system alive. Okay. Now let's move over to our gearbox plug. This one is really straightforward. It's pretty much only related to the gearbox, apart from the speed signal which you get there. So if you had a manual, we'd have a speed signal also be able to come through there. So starting from the top, we've got white with the blue, and that is your brake switch. So that's that one over there. Now that is a 12-volt signal that goes to the ECU. So you are required to connect that to your brake switch. Most vehicles, the 12 volts for the brake lights actually works its way through the brake switch. So just find that wire and you can supply that directly to there. Now it is fused inside the fuse box, so don't worry about protection. It goes through a 5 amp fuse before it goes to the ECU. So if anything happens to the brake lights, it's not going to do any damage to the ECU. That fuse should blow way before that happens. All right. Then next up, we have all the gear positions. So we've got black, red is park, red, blue is reverse, red, yellow is neutral, blue, red is drive, pink, blue is 2, and orange is low. So that's why if you guys are using a dash that has gear positions, so you've got park, reverse, neutral, drive, 2, and L, basically you can feed that to the dash and that will then show your gear position as you go through the gearbox on the shifter. But also if you want to fit your own LEDs for gear position, if your vehicle wasn't equipped with that you can do from that one as well. Okay, so really, really nice and straightforward. Then next up, number 8, we've got yellow with the black, and that's the overdrive off. Now on these older ECUs like the 92 to 94, they refer to it as overdrive off. Now remember, these are 4-speed gearboxes, and technically 3 is 1-to-1, 4 is 0.72 or 75. So technically 4th is overdrive, okay? And so basically with this overdrive off, you need to provide the wire with a ground/earth via a switch. And basically what happens is, like the 95 to 97s, it becomes what I call 3. Because effectively it won't let the gearbox go past 3rd gear, because 3rd is 1-to-1 and that is drive. As soon as you go into 4th, you overdrive. So if you supply the overdrive off with the ground, it will then cause the ECU not to shift past 3rd gear. Okay, so useful if you guys are towing like caravans, trailers, and you're going up a hill and you just want to get it down into 3rd and not let it go up into 4th. Okay. Next up is number 9, and that is red, and that is a kick down. So again, that wire just needs a ground via kick down switch. So remember, even though there is a cable on some of these gearboxes, it's not a kick down cable. Kick down is all electronic with these ECUs, and we give you the wire there, so you can put a switch at the back of your pedal. So when you put your foot all the way down, you close that switch, and then it provides a ground to our kick down switch there, wire there. Then number 10 is yellow, and that's PWR mode. So if you looked at your shifter in the original car, you'll see it's got a little button that says PWR, and then it's like nothing, and then or normal, and then PWR. That's like a power mode, so it'll hold a bit more revs before it changes gear, etc. Now that wire just requires a 12 volts, so you can run a switch inside your vehicle, label it PWR, ignition 12 volts on the one side, other side goes to our yellow wire, and there you'll be able to engage your power mode. Lastly is number 11, which is a black with a yellow tracer, and that is your speed signal. So as I said, with these 92s, they do come built in with a speed sensor plug, and it is in the gearbox at the back there. It's a usual 3-wire Hall effect sensor. We provided the 12 volts and the ground. We just give you the speed signal out so you guys can take that to a cluster, to a dash. And like I said, in this case, the customer's not actually going to use that. He's going to put a cable-driven speedo, which can actually bolt directly into the auto gearbox in place of that speed sensor, and that's how he's going to be powering his speedo on his dash. Okay, so hopefully that's mega simple for you guys. Again, all of our harnesses come with this. I give a detailed description of exactly how everything is connected, or how it is should be connected, and what it basically does. Okay. Right, so that's pretty much it for the layout and going through the fuse box connectors over there. So what I'm going to do now is scoot off, and then we're going to come back and we're going to start doing the testing. So see you guys in a second. Right, so we're back again, and now we're going to be doing the testing of the engine. It is going to be broken up into 2 sections, so I'm going to go through each one with you now. Then what we'll do is we'll jump into the ignition part of the testing, and then second part is with the engine actually running. Right, so let's start from the top over here. So with the ignition on, what we're going to be looking for is the check engine light, the charge light, and the oil pressure switch light. So again, it's all going to come up on the dash here. We're going to have the LED come on in the fuse box for the check engine light. Check engine light come up on there to show me that the yellow with the red wire is connected correctly. And then we're going to have the battery and the oil light over there as well. Okay. Then what we're going to do is we're going to test the brake switch. So basically I'm going to go to the pin on the ECU that the brake switch is connected to. I'm going to supply this with 12 volts and I'm going to make sure with my multimeter over there that we are seeing 12 volts. Then what I'm going to do is I'm going to go through the gear selector over here. So I've got it all hooked up over here. It's in park at the moment. So what's going to happen is basically I am going to start at park and I'm going to move my way down, and we're going to make sure that all the gear positions are correct and I'm getting 12 volts on all of them in the correct sequence. Okay, that's all the testing with the ignition on, so that's relatively straightforward. When we come to the engine actually running, we're going to start with the starter circuit, or neutral start switch as they call it. So we have wired this exactly as Toyota would. This vehicle will not start unless it's in park or neutral, and we'll do that by moving the selector from park into reverse. We're going to try and crank it by touching the black with the yellow wire with 12 volts. You're going to see nothing is going to happen, and basically the next step is I'm going to move it back into park and we're going to start the engine up. After we've done that, we're then going to obviously indicate that the fuel pump is working because the engine carries on running. Then what I'm going to do is I'm going to move over to the engine and I'm going to start disconnecting the injectors one by one. What I'm looking for is the engine to misfire, okay? So that would then indicate that all the injectors are working correctly. Now, do remember on a 92 to 94, you are actually running what they call semi-sequential injection. So 2 injectors are actually joined together and firing at the same time. Luckily, because of the distributor system, we are actually running a fully sequential ignition system. So obviously only one spark plug is firing at the correct time. So that's why you'll hear each one misfire as we go along there. Okay. Once we've done that, we're going to come back and we're going to go and look at the tacho and the coolant temp. So again, I've hooked up the coolant temp to that. So it's going to translate the data. So we should see our temperature gauge move up over there, and we should see our tacho giving us an RPM reading over there. All right. Once we've done that, we're going to move into the diagnostics. Now, what I have done for you guys is down in the bottom of the description, I've put a load of links for useful videos with this particular harness in mind. Also, a bunch of part numbers for spare parts if you guys need to get a bunch of servicing done as well. Now, in that video list, there will be one about how to do diagnostics. So it's a much more in-depth video. I'm going to show you the basics of how to do it here, but I do recommend you go and watch that video, and therefore you will have a much better idea of exactly how to carry out diagnostics. And I give a lot of tips and tricks in there as well. Right, so now that we've gone through that, let's start by putting the ignition on. And obviously then we'll start our testing. So first thing I'm going to basically do is I'm going to put the camera on the stand here. Okay. Hopefully you can see that. And all I'm going to do now is put the black with the red wire to 12 volts. And there you go. So again, let's move over here so you can see we've got the LED in the fuse box over there for the check engine light. We've got the check engine light on the dash, and we've got the battery light, and we've got the oil light over there. Okay. Right, so what I'm going to do now is to test the oil and the alternator light and make sure they are connected to the correct thing. I'm actually going to move around here and I'm going to disconnect the alternator, and we should see the light go out. So again, nice and easy with these DTM connectors. I'll just pop that out over there. And obviously you saw the alternator light was on, and now the alternator light has gone off. Okay, so that is working and we are connected to the correct thing. So let's put that back in again. So obviously we want the alternator to charge when she runs. Fantastic, so that's back in. Right, so as I said earlier, we've done a weird system with the fuel pump where we actually control it via the oil light. So I'm going to show you what happens if you hook everything up and you don't connect the oil pressure switch, or if your oil pressure switch is faulty and it's actually not grounding out. So watch what happens the second I disconnect the oil pressure switch, and you can hear the fuel pump kicking in there. You can see the oil light has gone off on the dash, and if I connect it again, you can hear the relay click for the fuel pump. You can hear the fuel pump stop running and the oil light comes back on again. So please be aware of that, because sometimes guys just don't connect everything up. Switch the ignition on and then boom, the pump just runs all the time. Now remember, that is quite a nice safety feature, because if you do lose oil pressure, effectively it's going to kill the fuel pump. So hopefully that might just save your engine in the event that you do lose oil pressure. Okay. Right, so that's all of the top 3 over there. So let's move our way onto the brake switch. So first thing we're going to want to do is obviously turn on our multimeter. They turn off for a pastime. Now then, let's go on to the what is effectively the brake switch wire. I'm actually going to put the camera on the stand for this because I've got the multimeter there so you can see it. Right, okay. So all I'm basically going to do, which you can't see, is I'm just going to connect this white with a blue tracer wire to 12 volts. And obviously what we want to see is 12 volts suddenly appear on the multimeter there. So let's make sure that that's in. And let's move this over here. Let's make sure I'm in the correct place. There you go. And there you go, 13.4, and then off again. Now remember, I have a battery charger on, so that's why you're seeing 13.4 volts as opposed to the usual 12.5 that you would see there. Okay, so what I'm going to do now is I'm going to be moving this gear selector, and I'm going to be moving the probe around between the wire in the different gear positions. And what you're going to see is the 12 volts appear as I do that. At the moment, I'm in the park wire. So again, you'll see that that is obviously showing there. Right, so let's start. So we're in park at the moment. I'm going to move it out of park. And you see the 12 volts then goes away. I'm going to move the probe down to the next wire, which should be reverse. And there we see our 13.4 volts. I'm going to move the gear division down to neutral. I'm going to move up to the red with the yellow wire. And there we get our 13 volts again. I'm going to move it down to drive. Again, that disappears. We're going to go to our blue with the red. And there's our 13 volts. Move it down to 2, and then I'm going to move down to the pink and blue, and there's our 13 volts. Move it down to L, and then I'm going to pop over to the orange there, and there you can see our 13 volts as well. Okay. Now what I'm going to try and do quickly is I'm going to try and show you something. So let's put it back into 2, and I'm going to wiggle the switch around. There you go. I haven't actually moved into a different gear position, but look at what it's doing. Fantastic. Okay, so that's going to help me explain the next point for you guys. When you are doing these swaps, obviously a lot of things are changing, and again, the selector or the arm from your actual shifter to your selector has now completely changed from the original car. One nice thing about having these particular gear position indicators is that you can correct that if it's in the wrong position. So you'll see here, and this applies to all of them, there's got an elongated hole over there. That means you can loosen that nut or bolt, and you can then actually adjust the selector switch, okay? Now, what I always advise people to do is, if you are doing a swap, is to either get a multimeter, or if you've connected it up to a like a light pod on your dash to show gear position, that's even better. But what I want you guys to do is basically get in, start the car. So you're happy now, everything's running, no problem, ready for a drive. Take it for a drive and boot it in a safe environment. Obviously, don't break any laws. But what I want you to do is I want you to boot it because I want you to put the engine under max torque, under max torque. Then the engine and so on will twist and so on in the chassis. And what you're looking out for is you're looking for the signal not to disappear. Okay. Now, yes, on the non-VVT-Is, not all of the gear positions do go to the ECU, but at least 3 of them do. Okay. So what I want you guys to do is to do that, because what will happen then is if you boot it, you're going to find out that obviously you lose the 12 volts on the gear position. And if it's one of those positions that the ECU is expecting to see, it's obviously not going to see it, which is less than ideal. So again, nice little thing for you guys to do. Get in, boot the car in a safe environment. And if you see the 12 volts or the light turn off, get underneath, loosen that bolt, adjust the switch ever so slightly, move it along, and boot it again until you can boot it as much as you want and you never lose that gear position. Okay, I see it so many times, and not on these engines particularly, but on the later ones, massive problem when the ECU doesn't see the signal. So your 1UZ VVT-Is, your 3UZs, ECU does not like having no signal for gear position at all. Okay. Right, so that is all the testing that we're going to do with the ignition on. So that's it. Yeah, we've done the brake switch, we've done the gear selector, we've done all the lights over there. So all I'm going to do now, as you can see, we've got no coolant temperature. I'm going to run the engine, get up to temperature. We're going to pop back, and then we'll do the testing with the engine running. So see you in a second. Right, guys, so now we're back, and we'll be doing the testing with the engine running. So obviously everything is done now. I've got the air pipe on, got the mass airflow sensor on. So quick recap of what we're going to be doing. First of all, we're going to test the starter circuit. So basically what we're going to do is I'm going to put it into reverse, try and start it. It's not going to start. Put it back into park. It's going to then start, proving that the neutral start switch does work, and the vehicle will not start unless it's in park or neutral. Next up is the fuel pump. So I want to make sure the engine keeps running. So again, telling us the fuel pump is working. We're going to go through the injectors and coils. So I'm basically going to unplug each injector one by one so you can hear the engine misfiring. We're then going to pop back and then we're going to look at the tacho feed over there to make sure that that is coming through. And then we're going to look at the coolant temp at the same time as well. Make sure that that is working. Then we're going to go through the diagnostics to show you guys exactly what to do. Okay, so as I said, first thing we're going to do, I'm just going to put the camera down for a second. Let me just get that down there. Okay. So hopefully you can see. Let's just do it like that. Right, okay, so at the moment it's in park. I'm going to move it over to reverse. I'm going to put the ignition on. And I'm going to take my black with the yellow wire and I'm going to try and touch it on the 12 volts. And you can see we get absolutely nothing. Now I'm going to move it back to park and then we're going to start it up. So let's do that now. Touch the black with the yellow wire. And there you go. Fantastic. Okay, so that means the starter circuit is working as expected to. Fuel pump is okay because obviously it still carries on running. Let's go over to the injectors and the coils. So we start here at injector number 1. So 1, 3, 5, and 7. Right, moving over to the other side now. We're going to do 2 here at the front. And then number 4 is buried down in there. Right, let's move over to number 6, which you can see is down there. And lastly, number 8. Fantastic, okay, so that's all good. Right, so we've done injectors and coils. So now we can see that we've got some tacho signal there. I'll give her a big rev. Right, so that works out. And then the coolant temperature, we just go down here. Coolant temperature, you can see we've got that coming through on the dash there, so that is absolutely perfect. So let me just quickly kill the ignition. Rightio, so now that that's done, let's get this on there so we can get ready to do this. So as I said before, what I've basically got is I've got an entire video on how to do the diagnostics on these particular setups. All right, so when you look down at your fuse box over here, you're going to see that there is an opening where it looks like there should be a fuse. You can see the 2 silver terminals there. That is not a fuse, and in your welcome pack, I do go through all of the relays and the fuses and show you exactly what everything does. That is what we call TC or trouble codes, okay? So what I've basically done is you saw that the check engine light turned off when we actually were running the engine, so we know we've got no issues that cause a check engine light or a limp mode. So what I'm gonna do now is I'm just gonna put the ignition back on again, because obviously we can't do any testing without the ignition on. So let's do that. Righty-ho, okay. So basically what I'm going to do now is I'm going to do exactly what I say in the welcome pack and obviously the diagnostics video that I go through over there. Now what I have done is, because with these early models like the 92 to 94, they don't even bring up a code for the secondary Lambda sensors. So what I did initially is I did actually unplug the mass airflow sensor, and I then ran the engine and then plugged it back in again, just so I can get some code so you guys can see what it looks like. So what we should have theoretically now is code 24 and 31. Right, so all I'm going to do now is I'm just going to pull the fuse out. Easier said than done. And all I'm going to do now is I'm going to touch the terminals over there, and you see the check engine light goes out, and it's going to start to flash. Now it'll go 1, 2, 1, 2, 3, 4. That's 24. And we're going to have 1, 2, 3, and then it's going to be 1. That's 31, and that's the mass airflow sensor. That's the 2 codes for that. You see we have a long pause, and it's going to go 1, 2, and then it's going to go 1, 2, 3, and 4. Okay. So As you can see there, we had 2 flashes, then a little pause, then 4 flashes, and that Beck's 24. That's your intake air temperature circuit. Again, I unplugged the MAF. And then 31 is your actual mass airflow calculation error. Okay, so 24, 31, if you get any of those 2 codes, that is the mass airflow sensor relation code for that. Okay, again, in the description, there's a link to a full-on diagnostics video that I have done for you guys. So again, I would recommend to watch that. And obviously, further on the line, if you do need to do some diagnostics, you might want to watch that to refresh everything for you. But obviously that demonstrates why it's super important to have that red wire connected to a permanent 12-volt source, because even though I managed to clear the code by plugging the MAF back in again, it still stored those codes for me. And what you guys notice with this particular ECU as well, if there are no codes, it'll just do a constant flash. Okay, just literally flash, 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 flash. No sort of no like 2, then pause, then 4, then 3, then pause, then 1. Nothing like that. It just has a consistent flash. That means you've got no codes on there. So usually if I had to reset the ECU now by unplugging the power and plugging back in again, you'll see this is going to do a constant flash there. Okay. Right, so that's basically it, guys. Again, if you have any questions, as per usual, please feel free to comment down below. We can always do videos on things you guys don't know. Usually we just have to wait until something comes in that we can do the video on. If you have any questions, obviously, about pricing in relation to this, then again, you can just message us either at our Facebook page or info@phoenixenginemanagement.com. We'll get back to you as soon as we can. But yeah, if you guys are looking for quotes, just a little heads up.